There's always something new from our sponsor, Text Control. They just released version 30 of their document processing library that includes new document collaboration features. Using TX Text Control, you can integrate online document editing, document signing, collaboration, and PDF processing into your ASP.NET and ASP.NET Core web applications. Whether you need to create PDF invoices, quotations, or reports, TX Text Control provides the developer libraries for all document-related tasks. Check out the new features and see their technologies in action by visiting the live demo at demos.textcontrol.com. That's demos.textcontrol.com. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes, and today we're chatting with Eden Fulgo. She's the founder and CEO of Mobot. How are you?
Hey, Scott. Thanks for having me.
If you go to mobot.io, you are greeted with this wonderful autoplay GIF or video of a freaking robot with a little stylus like speeding through tests, and then it zooms out, and then there's another one and another one. And I just imagine that there's like a giant warehouse or a cloud or a giant Costco filled with tiny robots and thousands of these things. Did you build a robot army to test phones?
That's right. I started Mobot because I was working as a product manager and I had to do way too much manual tapping on a pile of different iOS and Android devices. And just after one too many late nights, I was just like, enough is enough. There was apparently no way to really automate mobile app testing effectively with software. And so I decided to take an approach of like, okay, let's use actual real mechanical robots with real end effectors or robot fingers, tap on touchscreens, and automate testing that way.
How often do engineers hear about this, learn about it? First, there's that, wow, robots for testing. And then how often do they just completely minimize or diminish your thing and just say, well, that's just dumb?
Yes. I think a very common reaction, especially from engineers that spend a lot of their career building web apps, or maybe they're on the back end, is there's this reaction of, oh, shouldn't you have a unit test for that? Like, why would you ever need to use hardware to solve a software problem? And I think one of the things, and I've spent a lot of time trying to find the most beautifully crafted answer for this, but ultimately what it comes down to is the mobile tech stack is wildly different from the open source web. It's very different from a lot of other tools that are out there. And so there's things like Selenium or Cypress or a lot of RPA tools on the market really just actually can't work with your classic iOS or Android device. It also really doesn't help that iOS 16 just came out, iOS 14 Pro, the iPhone 14 Pro came out. Now there's like Dynamic Island. There's these features that are changing all the time. And as an engineer that has to build for these ecosystems, it becomes so difficult to actually keep up with everything. And there's not a lot of automated tools to support testing for that. So what ends up happening is Apple could drop iOS 16 whenever they want. And then you have to respond to it right away. You build a new feature. They haven't even built the testing framework so you can support it. And so you end up having to manually tap with your finger on your personal device to actually get it to work and making sure that everything still functions as expected. And so the approach that we're taking at Mobot is, okay, right now this problem is about iPhones and Android devices and tablets, but 15, 20 years from now, what is this actually going to be? Like, there's more IoT devices than ever. Hardware is getting easier to manufacture than ever. Are we going to have robot contact lenses with software that play in your eyeball that we need to test? Like, then we would need a robot to test that. So my broader thesis for Mobot is how can we build technology that actually tests the way that humans use products? Because you're not just sitting in front of a laptop typing away on a browser anymore. You use it with your Apple Watch when you're running. You use it while you're, connected to a Bluetooth earbud. There's all these different ways that software interacts with the real world. And my opinion is we need to develop a new generation of testing tools to support that.
I want to make sure we expand our acronyms for folks who may not know them. At the very beginning there, you said RPA. Is that robotic process automation? That's a whole class. It's a whole industry, RPA.
That's right. So RPA, robotic process automation, refers to the use of metaphorical software robots to automate desktop and web app testing. And so it's funny because sometimes when I tell people we use robots to do testing, the immediate thing you think of is like a chatbot or something in the cloud. You don't think of a real robot finger tapping on, a touchscreen glass.
Interesting. So the whole industry of robotic process and automation only recently has included actual robots like we think about.
Yeah, and we don't really use RPA to refer to Mobot because it gets so confusing with the metaphorical software robots.
hmm Yeah, and things like Playwright and Cypress and Selenium, they instrument the browser on the website and they like have a DOM, the document object model that they can poke at. And I've always wondered if there was a bit of an observability problem there, kind of a Schrodinger's cat of testing, because once you've observed it, you've changed it. These are instrumented pieces of software that we're not really touching the touchscreen and how the touchscreen it behaves.
Yeah. So the nice thing about web app development is that engineers, when you're developing your products, you have full access to the DOM and you can build tests and you can clarify the expectations and the outcomes. But what I've realized about a lot of mobile app development is when you're building native iOS and Android apps, the DOM, there's just not an exact equivalent for the DOM for development. And there are certainly tools you can, of course, use XCUI as the testing framework on iOS. You can use Detox if you're building a React Native app. You can use Appium, which is also another open source testing framework, but you don't have the same control. And I think some of this is because the iOS ecosystem is closed source. And so engineers, when they're building iOS apps, just don't have as much access and control over the application as they would expect to on the web. And there's a little bit more accessibility on Android, but it's also just similarly constrained. And the other complexity with Android is because it is more accessible. There's all these different Android manufacturers that have their own flavors of and implementations for Android. Xiaomi has their own implementation. Huawei has adapted to Harmony OS. Samsung has their own layer that is applied on top. LG, when they were making phones, and a lot of LG phones are still actually being tested by Mobot because real users still have them. It's actually incredibly complex. Even so, there's like pros and cons to kind of both iOS and Android. But the way that Mobot is trying to avoid the problem entirely is if we just poke at the phone, as a black box, regardless of the other layers of software that are applied at the mobile operating system level, we can realistically test the end user experience exactly the way that a human is going to be experiencing the mobile app.
That's so interesting. So I came into this thinking, what a complicated way to test things. And now that you've explained it, I'm thinking, well, that's far simpler than dealing with test harnesses for all these different manufacturers and whether or not they have standard or non-standard software. So while people are trying to build standardized interfaces and come up with, worldwide standards and stuff and make us all agree, you're poking at the phone with a stylus because that's what users do. They poke at it with their finger.
That's exactly it. And I think we're moving into a world where things are not as standardized, but because everyone is able to innovate on their own platform. And so the best testing framework can adapt to any standard. And so right now we're very much focused on iOS and Android because that is what a lot of engineers out there need the most help with. And that was what I personally struggled with testing. But in the long term, we'd love to be able to test your Linux based grocery store checkout kiosk or your Nest thermostat that has or the digital the crown on your Apple Watch that needs to get spun in order to get the water lock out. Like, we basically want to automate anything that a human could do.
That was exactly where I was going. It was like, wow, you could just lie the thermostat down and poke at it exactly the way, or any IoT device ultimately. So this is mobile testing, but it's really IoT testing. It's anything a human can press with their fingers, and with everything being a touchscreen, anything at all, a transit terminal you could test with Mobot.
Yeah, like that's really the thesis is we think the world is getting more complicated. Everyone's building their own hardware, everyone's building their own ecosystem because they have their own vision for how the world works. And so as software engineers, we have to build for all of these different platforms and want to make sure that you have a consistent user experience. So just test it the way a human does. And that way you don't need to worry about, oh, does this library for testing support the latest version of this firmware, or this, this hardware implementation is different on this device or these dimensions. Like we really want to kind of simplify the whole testing process, especially because engineers have enough to worry about as it is without having to think about the physical variabilities.
Right. Okay. So you want to simplify everything. So I'm gonna do a gotcha question. Surely I'm gonna have to learn some custom programming language that you all invented. I'm gonna have to write out custom test plans. How am I gonna define my test?
So our long-term vision for Mobot is we essentially want to build a self-service farm of robots that you would be able to just log into mobot.io and you'd be able to say, I want to test on an iPhone 14 Pro running iOS 16. And on that platform, you'd be able to get a real live stream into a robot, like robot number 54 is available. And you can just point and click on your browser screen and you'd be able to program the robot live and it would do what you want and you'd be able to run your tests. And so the robot can then loop that test back and keep running it the next time you have a build. And so that's really our long term vision. You can imagine building robots that tap stuff in the cloud is incredibly ambitious. So we're not quite there yet. So our intermediate kind of implementation of Mobot is we work with a lot of teams and provide also a testing service where if you give us your test expectations and your test cases, our team will program the robots for you and we'll make sure and commit to getting it all done on all the different devices that you want us to run on. And so in that way, we can kind of not force our customers to have to learn a robot programming language. We also don't want to build a robot programming language. We want to build this no code point and click tool where if you point and click in your browser, you can tell the robot what to do.
See, that's cool. Make a video of my. Here's my test case. I recorded my screen. This is what I tapped on. Do that, except for real. That would be amazing.
Exactly. That's exactly it.
Oh my goodness. Okay. And these robots, I'm a 3D printer person, and I've noticed that, the quality of stepper motors in the last 10 or 15 years has just been gone up like a hockey stick. So there are standardized and high quality DC stepper motors and things now. Are you making these custom rigs for a robot? Could I test an iPad or a large tablet? How do you adjust these things, and what do you build them with, off the shelf parts?
Yeah, so when we started Mobot, we really kind of thought about what are the other kinds of robots out there that are on the market. There are hobbyist robots. There's industrial touchscreen testing robots that cost like 50 or 100 grand. And ultimately, none
Mm-hmm.
of the solutions really fit our needs because what we need to do is be able to control the robot ourselves. We want to be able to kind of manage and swap out different parts. We also want to be able to scale and control that process as well. So we actually ultimately made the decision to build our own robots and do so using commoditized off the shelf parts. So if there are supply chain considerations, we can swap out different parts and just like make sure that we own that technology piece end to end since it's so critical. And because we want to be able to actually do our own maintenance and be able to adapt and evolve the platform over time. And so, yeah, we've over time kind of customized an off the shelf pen plotter robot to a point where it's basically a lot of it is our own kind of customized use case for using it. And yes, we've also realized like touching a screen with an end effector, like it doesn't need to be super precise. So we can, sometimes just like a simple hobbyist gantry design is actually sufficient. But over time, we've calibrated for our own needs, and it is something that we feel comfortable scaling.
That's so cool. I love that. I visualize it because you called it a pen plotter, and I
Mm-hmm.
understand those things now. That's so cool. And being able to do those with some of these high quality off the shelf parts. But it's like the good example is Lego. Like when I look at something that someone builds with Lego, it's like, I could never build that. That's amazing. But then you look at the individual parts and you say, wow, that's so simple. And you've literally taken something, summed it up, and it's far more than the sum of its parts. And that is the magic of what you do.
Yeah. And I think the other piece of it is absolutely like an engineer, if you had enough time, I have no doubt that software engineers could also build their own robot armies to test stuff and they wouldn't need Mobot. But I think part of what we're
Nah.
really trying to do is make it easy for the everyday software engineer that, yeah, doesn't have time right? You need the testing done, and then you want to be able to move on and ship your next PR. And so really, like, our focus is how can we use the robots to deliver a very efficient testing service so you can get the answers you need. Here's the log, here's the device console output, and you can go back and trace, like, what was the network call that was made, and then, like, oh, that was where the issue was, and then you can move on and do something else. So there are absolutely, depending on the use case, some engineers who will want their own robot, but for most iOS and Android engineers out there, just having a testing service do it so that they can get the answers is more important.
I totally agree, and I hear you. I do think, though, it's the robots are only half of the value proposition. The other value proposition is I don't have a Samsung, whatever, an HTC H1 or a Surface Duo. I'm going to have to source all of these things as well, and I'm only going to need them for the tests. So it's like a rental car agency. It's like I just need a Nissan Altima for a weekend because I've got a bug on that thing. So I can rent time in the cloud, and you've not only built the robots, but you've sourced the physical hardware, and that's a huge value add.
That's right. And also, the other thing we've just really embraced as a part of Mobot's identity is the process is a combination of robots and humans. I think, as a lot of technical professionals know, like, there's no magical AI, there's no free lunch, right? Everything needs to get clearly defined. A robot will only do exactly as you tell it to. And so the reason that Mobot is an efficient process is because we have robots doing the predictable, deterministic stuff, but then we also have humans that are ready to oversee the robots and provide feedback when something changes. And so we can actually use that as an opportunity to live update test plans as they're being run. And so that solves the other piece of the software testing problem, where your code is constantly changing faster than you can design tests to keep up with it. And it's an even worse and more aggravated problem on the mobile side because of how complex everything already is. And so what we're trying to do is essentially robot run stuff. When something changes, we reprogram the robot live and keep it going. And then that becomes the new version of the test that you run. And so that piece of the human supervision and oversight and review with the robot doing the regression testing, with the actual consistency and calibration that we can maintain on 250 plus iOS and Android devices, that's kind of the entire Mobot secret sauce. It's everything. It's not just the hardware, it's not just the software. And I am not afraid to admit that there are people as a part of the process. And I really do think that robots are not going to replace humans' jobs. Like, I think it will allow us to do jobs differently.
Yeah, that's a really great point, and that's why I think I've seen you call it an observed and a supervised robot solution, because my 3D printer works amazingly 99 times out of 100 until it does something crazy, and then I've got spaghetti, and I can only assume with any robot touching anything that can happen, and that's why those critical test scenarios do need to have observation. And I love the idea of being able to have a webcam where I can watch the tests in my robot cloud somewhere do them for me. That's so cool. Let's take a moment and thank our sponsors, Seek. Keep sensitive log data entirely within your own infrastructure using Seek. Whether you use Serilog, Nlog, or .NET's built-in logger, Seek gets you centralized search, dashboarding, and alerting, all without having to share your data with third parties. Check it out at datalust.co/SEQ. That's datalust.co/SEQ. If you don't mind, I want to turn a little bit towards something like how you got here, because your story is pretty fascinating. And if you're not offended, I went to the Wayback Machine because I was looking on your site, and there were a couple of dead links, and I found one that was your goals. And this is a long time ago. I mean, this could have been maybe 15, 20 years ago. And I've been blogging for a long time as well. So, I have vestigial pages as well. And this is just great, though. This is a simple list of your goals. You have red goals that are in progress and green goals that have been accomplished. Some of these goals go back into the 90s, like become a scientist. You crossed that one out and you changed it to become an engineer. How did scientists become engineer?
I think I realized partway through that I like making things more than I like answering questions. And I think that was kind of like initially, when I was just very young and probably 6 or 7 years old, like, I was first introduced to the scientific method. And so I thought it was really cool that you could have a problem and then come up with a hypothesis and then go through the scientific method and figure out, if your hypothesis was correct or not. But then the more I got into it, I realized actually I want to be like physically, tactilely solving real problems, building something, inventing something, and not just investigation. And so that was kind of how it naturally evolved into more of an engineering role for me. But I think in the early days, I was very privileged to have the opportunity to actually, compete in science fairs. From grades 5 through 12, every single year, I competed in the regional science fair, and then, in the later years of high school, had the chance to actually go to the Intel International Science and Engineering Fair, which I think shaped a lot of the person that I am today. I didn't win every single year. There were many years where I won nothing, and it was really embarrassing. And that was kind of like early exposure to startup life and what it's like to try something, sell something, see if it works, doesn't work, you iterate and you keep doing it. And I think that process from, you know, age 10 to 17 was actually like really important for me.
Yeah. And now, many, many years later, though, I'm getting the impression from just a very, very light internet stalking, just Googling around and learning about you. You appear to be very intentional about what you're doing. You're not just going through the motions. You write things down, and you also unapologetically put goals on hold, change them, and even cross ones out that have been abandoned. Have you always been a list keeper, a goal maker?
I've always been very achievement oriented, I think. I like being able to like set a target in the distance and then go and hit it and then feel that sense of satisfaction that I am better today than I was yesterday. And it's always sort of been like that for me. And some of it is maybe just like a natural competitiveness. And I think like that a lot of that like shaped my earlier years of just like knowing that, hey, if I set that target and actually hit it, and then I feel that accomplishment, like I can keep doing that over and over again. And if you do that, it compounds over time into a real career and a real lifelong passion. And I think I can't even really separate like what is an individual goal and what is something, kind of inspired by a lot of different goals compounded together anymore. Like it all kind of blurs together for me.
Yeah. Well, this particular goals list is quite long. I mean, there's probably 40 goals here. One of the things that struck me, though, is I would have assumed, ignorantly, thinking about people in my life, that you'd have a lot of goals that compared you against other people. But other than one goal where you say, I want to win a gold medal at this science fair, these are very personal goals or very introspective. It's all self improvement. You're not like, be first at this and be first at that and get a gold medal at this. It's really just be better tomorrow. Almost all of these goals are making yourself better. And I think that's really cool.
Yeah. I think I ultimately realized it's easier to measure success if you know that it's something you can control. And who I was yesterday, am I better today than I was yesterday? That's something that is entirely within my control. And I also think there's a control piece of this. Maybe I'm a control freak. There's so many parts of this that we could
Well,
explore.
you have a robot testing company. I think you are a control freak, and that's why you're so good at your job, right? I mean, to your credit, I think being a control freak worked out for both of us.
Yeah. Yeah. So I think it all kind of makes sense if you look back on just like my childhood interests and my how I naturally leaned into STEM and the decision to study mechanical engineering. It all kind of flows together, and I'm grateful that it's led me to starting Mobot today. And I think that also kind of helped me have an unconventional solution to this problem. And I think there a lot of people ask all the time, like, why has no one else thought of this? Which I do think people have thought of this. There are other robot companies out there for testing mobile and for testing software. But what's different about Mobot is we're doing it as a fully integrated service, and we're also building our own hardware and software. But I think part of it is like, yeah, it takes kind of thinking outside of the box and being like, how do we really just get to solving the problem rather than trying to
Mm.
find the most theoretically elegant way to solve software testing for mobile, which I've spent a lot of time thinking about that too.
Yeah. It initially caught me as like, wow, that's weird. And then I was like, well, that's actually makes total sense. It's quite intuitive because I'm really interested right now in Playwright and Cypress and Selenium. And I've been doing Selenium testing since 2006, 2007.
Hmm.
But when you go into the browser and into off the browser and into mobile, you start thinking about things like Appium. And then again, with iOS, it's extremely challenging to get reliable tests. And you find that a simulator works one way and an emulator works another way. And then the physical device didn't work the way I expected. Why do simulators not perfectly simulate reality?
Yeah, I think also part of it is there's the assumption that like your app is open in the foreground and the tests that you are
Mm.
designing are often like, there's no other apps installed on the device or that, you're able to fully replicate that graphics card, that memory on the device. And there's no push notifications or, location is in a certain way or in a certain state. So I think like there's a lot of different variables in the real world. And I think that kind of ties back to the bigger theme. And so when you try to use a simulator or an emulator or a virtualized real device in the cloud, which they always say real device, but it's just a device on a rack somewhere that's plugged in via USB, you're still sending simulated touch events to it. It's not actually the same as my finger poking on the screen with all the other apps I have installed and then making sure that if I background the app, is the data still syncing? Or if I'm also using a third party API or a custom camera library, is it actually able to grab the images and edit it? And so there's all these kind of the broader theme here is also that our software more than ever has to talk to other people's SDKs, other people's APIs, third party dependencies. You have to use a social media app that links to your deep link and then into your native application. You don't control that social media app. How do you make sure that that experience, that end user experience, is entirely consistent? And so, a lot of these testing frameworks, they don't let you automate other people's code, and you also usually have to have access to it in order to do that. Whereas Mobot can literally automate anything. So that's a big piece of it is that a lot of testing frameworks out there presume your app is in the foreground all the time. But it's not these other realistic edge cases that do need to be tackled.
Yeah, that's so interesting. So you've got a whole number of success stories you can go and check out at mobot.io. You can test really anything. Like you test games, mobile games, to be anything at all. Anything someone can touch, Mobot can test.
Yes.
Enterprise apps, in whatever it is.
Generally, we highly prefer if it's something deterministic. I think games, if there's like an onboarding tutorial or we want to tap
Mm,
on,
good point.
an in-app purchase or signing up for an account, I think those are very
Yep,
doable flows. But if we get to a point
the
where
fragile
there's
parts.
yeah. And I also think like the initial first impression that someone has of your experience, like that's where a lot of companies, games or otherwise, spend a lot of time really trying to make sure that that end user experience is business critical, and that it works and it's consistent. Like if you sign up for an account and you're between the ages of 13 to 17 versus 18 or higher or something, what does are you able to fill out all the different fields and all the different pathways, especially for fintech apps? If you uploaded your passport as validation versus your driver's license versus an invalid or valid social security number, sometimes those things can be very hard to automate end to end. One of the tricky things I realized with one of our customers was you could open a debit card and there's a signature pad on the screen and you can draw a line or draw something and that's your signature. It turns out they were embedding a web view inside the native app because it was really hard to build the native component for the signature pad. So they just threw in a web view. When you do embedded web views inside native apps, it's very, very hard to test that with a software testing framework. You can test the web view itself with Selenium. You can test the native app with Appium, but the embedded
Mm.
web view in the native app is like this weird gray area that no one's library seems to cover. But Mobot is just like, it's an app. It looks like a view. I'm going to tap it and draw a line for the signature pad.
That's so cool. And even things like rotation, which again, you can simulate, or I can just rotate the thing and let's test the gyro as well.
Exactly. Yeah. So
Yeah.
we go through all sorts of things, landscape and portrait orientation, making sure all your UI components, the tap areas are correct, everything. I will also say, like, what we really try to do at Mobot is make it very clear. We're not competing with the Sauce Labs or the UI emulator testing frameworks of the world. We're not competing with browser stack. We're not trying to replace your unit tests, right? There's really this testing pyramid where at the very bottom, you have to write unit tests. You have integration tests on top. And then you have automated UI tests that are probably written in Appium or Detox or XUI or Espresso that you should have. But the top of the testing pyramid is, I think, deceptively large. And people sometimes forget how complex it is, especially with all the devices and all the other stuff we talked about. And so because that top of the pyramid is actually scarier and more daunting and more complex than people think it is, that's the opportunity that Mobot is actually going after. Is we've realized a lot of engineering teams are have tried to automate these things and realized a huge chunk of it, like we're talking 50-60% of test cases cannot be automated with software. And so they end up just falling back on it manually. Sometimes it's your customer support team doing the testing. Sometimes it's the marketing team. Sometimes you have a proper QA team that ends up doing all of this testing, but then they don't have time to spend building automation and writing Selenium or Appium tests. And so it's this trap you get caught in, and Mobot is here to help engineering teams and product teams break out of that trap.
Very cool. Well, thank you so much, Eden Fulgo, for chatting with me today.
Thanks, Scott. This was awesome.
We've been chatting with Eden Fulgo. She's the CEO and founder of Mobot. You can check them out at Mobot, Mobot.io. This has been another episode of Hansel Minutes, and we'll see you again next week.